Hey guys, my name is Noah Housley, and I'm here just giving a review of each day in class for my own personal study and for anyone else's help as well. Hopefully these are quick enough reviews. So today I'm going over in Math 302, 13.1 and 13.2 first day of lecture. First thing we talked about was space. Space meaning different from the normal Cartesian coordinate system of an xy plane, where we're used to an x and a y coordinate system. Excuse my handwriting, by the way. He talked about in space, there's an x, y, and z planes. And he called them planes specifically because when you have this plane, it's meaning that there's something acting in that plane. So for example, if I only have an x and y coordinate system, I'm acting in the x and y plane, which is the plane that's acting flat right here. So for an example, I've drawn the plane y equals 1. And that gives you the plane that you see here, attemptedly drawing here. So this is helpful because when you're looking for something and you say, for example, one of the book problems was, give a plane that goes through this point, and it'll say on the x and y plane. And so if there's a z point on that, you know that there's a fixed z point, but it's on the x and y plane, so you have you would have a plane of, well, let me just give the example of, like, if I have 0.314 on space point, then, and I want it's on the x and y plane, then what I'm going to do, if I have x and y here, but that's 4, and so I know that's 4, that's a fixed, that's a fixed point that I have to go through, and these are variable, so I know that my equation for this plane is going to equal z equals 4. And why that makes sense is because if I come up to z equals 4 here, and I draw this plane on the x and y axis, then I have it going through that point, but also going through the points of x and y, 3 and 1. Okay, very good. Next thing we talked about was the distance formula. Now this is based off the Pythagorean theorem, and it's given like the Pythagorean theorem of new x minus original x squared, same for y, same for z. That's just the distance formula. And then it's all square rooted. Since this comes from the Pythagorean theorem, you could square both sides and it'll look exactly like the Pythagorean theorem. That's also how you get the equation for circles. So you could do the same thing for a circle, and then you can find r where it's centered at. I drew an example, r squared equals x squared plus y squared, where this is centered at 0. This translates R3, which is the three-dimensional space, to r squared equals x squared plus y squared plus z squared, where this will give you a sphere. And I've discovered that it's really hard to draw spheres, just by the way. Okay, so let me do this problem, example problem that was kind of emphasized. It looked like the most challenging thing in class so far. So it's completing the square. So we have something like this, and we want to find out, that's a 2, by the way. We want to find out if this is a sphere or not. So first thing he mentioned when this is, to identify that this is a sphere, is that there's nothing in front of the x, y, and z squareds here. They're all squared here, and then there's a z, a y, and another y there. Oh, z, y, and x, that's what I meant to say. So we see that this could be an equation for a sphere. The coefficients are 0, even if they were, they could be factored out. And so it might take some practice, but we can recognize that this is a sphere. So first, to complete the square, first I'm going to separate terms, x squared plus 2x, y squared minus 4y, z squared minus 6z equals 2. To complete the square, what you're doing is you're trying to get them to a point where it can just be a squared binomial. And so to do that, you take x squared, you're going to cut this term in half. So 2 and a half is 1, so plus 2x, and then you're going to square that, so plus 1. 1 squared is 1. And if you factor this out, you see that x plus 1 squared does in fact equal x squared plus 2x plus 1. So if I do that quickly for the next two, y squared minus 4y, and then cut it in half, squared, that's cut in half is negative 2, squared is positive 4. Then I have y squared minus 2 squared, z squared, negative 6, cut in half is negative 3, squared is 9, so I have negative, or 6z plus 9, z minus 3 squared. So what I did is I added a 9 here, I added a 4 here, and I added a 1 here. So I have to do that to the same side on the equal side. Then you see that 9 there, 4 there, 1 there. So this all equals 2, but now it's 2 plus 9 plus 4 plus 1. That's 5, that's 11, that's 16. And that's r squared, remember, in our sphere equation. So we have x plus 1 squared plus y, that's not squared, y minus 2 squared plus z minus 3 squared equals 16. R is 4, and this is centered at, you just take the opposite of each one. Since it's just one coefficient, you're equaling to, or technically trying to have them equal 0. So this is centered at x is negative 1, 2, and 3. Looks like we got that right from the one in class. Very good, let's move on. All right, then we talked about vectors in class. It's good to know that the length, magnitude, and norm are all the same thing, and you can find the norm slash magnitude, or it's usually notated by the double line thing. So I put an A vector in there notated by double lines, which means magnitude. You can find the magnitude, say we've got vector AB here, which is named by a point, and you can find it by the Pythagorean theorem, square root of 1 plus 0.2 squared. It's good to know that we can do scalar multiplication. What you do here is you just factor whatever coefficient in front of the vector, and that'll be scalar multiplication. A good example is this is if you have 3, and then you could have 3i hat plus 4j hat minus 5k hat. And that would be a scalar multiplication there. So what you do is just factor in here. So vectors are parallel. I thought this was an interesting point, and it was brought up in the homework. The vectors are parallel if multiples of each other. So for example, back to this one, if we had just 3i plus 4j minus 5k and compared it to this one, these two would be parallel because they're going in the same direction. The magnitudes are the only thing that are different, and so then they'd be parallel because they're in exactly the same direction. Good to know. All right. My favorite form of vectors is the unit vectors where the magnitude equals 1, and that's this I hat, j hat, k hat junk going on. Okay, if you have any questions, leave comments. I might see them, and I might know how to answer them too, but this is great for my study. Thanks for listening.